there are various different methods for doing experiments, and we'll be talking about those a little bit today as well. And I think once you've got your objectives clear for the experiment, then you can choose your method, the most appropriate method to get there. What would your objectives be? What are you expecting the students to learn about with this experiment? Forces and gravity, very good. Shapes, what rolls and what doesn't. But what am I talking about if I talk about the scientific method? Good. That's a key word there, hypothesis. Okay, the question, very good. Steps to follow, hypothesis, demonstrate something. Question, hypothesis, experiment, conclusion, very good. And this is one of the key stages. An experiment should always answer a question of some kind. It's very important to choose an appropriate question, and if that question can come from the students, better. So if you can get the students to be asking appropriate questions, that's even better. Sometimes you have to guide them, and then you have to decide what the best scientific method or the best experiment method will be to answer the question. So from the question, you'll then decide where you want to go with that, how you want to answer that question. What kind of question might we be trying to answer there? What kind of question do you think the students might come up with if you show them that picture, or might you try to elicit from the students with that if you want them to do this experiment? What shapes roll? Good. Will they roll? What will happen? What do you think? Okay, so the students then need to create a statement that predicts the outcome of the experiment. Again, it should be student-led. You could get them to think, pair, share. So think about it individually, maybe write some ideas down, and then talk to a partner, compare their ideas, and then share with the rest of the class. Other experiments, like for example, watching yeast inflate a balloon on top of a bottle, you have to leave the yeast in warm water with sugar for quite a long time before it will start to produce carbon dioxide. So it takes a long time. So once you've set up the experiment and started the experiment, you then need to have another activity planned to then come back and look at the results later on. Or if you're observing how plants grow, then it's going to take several weeks for you to collect the results of the experiment. So you need to think about, can I do this once very quickly in class? Does it need to go over a couple of classes, or will it take the whole of the class, in which case, should we go to another activity and come back to it, or is it going to take several weeks? And if it's going to take several weeks, how are we going to record the data, and where are we going to put that while we're waiting for the next set of data to come in? Okay, so timing is quite important as well. I really like using these as a way of eliciting questions. As you can see, there's a snowman here, and 3 of the children in the picture have different ideas about what will happen. They're making their own hypotheses, and I think this is a really nice way of introducing to the students that hypotheses don't always need to be correct, and the more different ideas or hypotheses we have in a classroom, the better the learning experience is for everybody. The only thing I have left to say is thank you. Thank you for being such wonderful participants and for participating in the main chat and also with your groups.